Hello, my name is Jeff Crowley. I'm a remedial project manager for the Environmental Protection Agency based in Atlanta, Georgia. Today I'm going to talk to you about the new phase of the Alamo Contaminated Groundwater site, and that would be the remedial action. So now I'd kind of like to give you a brief agenda for what we plan to cover today in the presentation. First of all, if you can see on the left-hand side, this is the journey that we've gone down at the site. So it started with the preliminary assessment and the site inspection. And that is the initial phase of the project where we came out and did some investigation of the site to determine whether or not the site would warrant listing it on the national priorities list. And the national priorities list is the national list that is voted on actually by Congress, and it is sites that they deem should get special funding in order to address the contamination present. That has already happened at this site. Then over the past few years, we've been working on the remedial investigation and the feasibility study, RIFS. The remedial investigation is where we do a full in-depth site characterization level investigation of the site. And the feasibility study is where we determine some options for how to remediate the problem. Back in 2018 in September, I spoke to you guys about the proposed plan that we plan to take at the site. And later that month, we signed the Record of Decision. Since that time, we've been working on the Remedial Design, or RD, which allows EPA to come out and field test some of the remedies that we selected in the ROD to see if they've been scaled appropriately and to see if we need to make any changes to those plans. And so that brings us to the remedial action. So today I'm going to give you a brief site background, talk about some of our previous activities, talk about our remedial action objectives or the goals that we expect to achieve after the remedial action is complete, give you a brief summary of what to expect during the remedial action, some potential impacts that you may experience in the community, and then a timeline of events going forward. So here's a little bit about the site background. In 1988 and in 1989, volatile organic compounds, or VOCs, were discovered in Alamo's municipal wells number 1 and number 2, respectively. In 1991, the city of Alamo installed an air stripper, I'll talk a little bit more about that later on, and began quarterly monitoring of the groundwater. Over the next decade and a half or so, EPA and TDEC held multiple investigations of the Alamo groundwater and contamination plume, which led to a 2011 National Priorities List listing of the Alamo Contaminated Groundwater site. And then from 2013 to 2018, the EPA conducted its remedial investigation, which is where we come out and fully investigate the town, see if we can discover any sources, see if we can kind of characterize the contamination as it lays in the town. In September 2018, as I discussed before, EPA signed the Interim Record of Decision, documenting our plans for how to remediate the site. And in 2019 and into 2020, EPA conducted the remedial design. This is just a list of definitions for the site going forward. I'm going to use some of these terms interchangeably. I'm not going to read through all of these here right now, as you can see them on your screen. I'll pause for a minute just so you can take them in. Thank you. So now I would like to talk about the Interim Record of Decision that was signed September 27, 2018. This document outlined the major components that EPA plans to implement in Alamo to remediate the contaminated groundwater. The first thing we plan to do is install and operate a soil vapor extraction system near the former Ward's Dry Cleaners building in order to remove contaminants that may have stayed in the soil that could be leaching down into the groundwater as a potential source. We're going to cap the area near the SVE system by applying sealant to the existing asphalt pavement. We're going to install a new low-profile air stripper to replace the aging town system and implement some institutional controls going forward to restrict new groundwater use at or near the site and prevent human exposure to contaminated groundwater. In the interim record of decision, these are the following remedial action objectives. For the soil, we wanted to prevent the migration of contaminants in the soil that could result in groundwater contamination in excess of our federal or state ARARs. And for the groundwater, we wanted to prevent unacceptable risk to human receptors from exposure to the groundwater used as the source of the town's drinking water. And we want to restore the groundwater that is considered a drinking water source threat to the beneficial use of the community. So a little bit about the remedial design, which was conducted in 2019. Again, this is the phase in the Superfund site cleanup where the technical specifications for cleanup and remedies and technologies are designed. And the final design of the soil vapor extraction system and proposed sampling schedule were developed going forward and field tested. And it was reviewed by EPA's National Risk-Based Priority Panel prior to funding. This is a fund lead project, and what I mean by that is that the EPA is going to be paying for this remedial action. There's no responsible parties at this time that will be contributing to the cleanup. So now I'd like to talk to you about the air stripper component of the remedial action. As you know, Alamo has had an air stripper in town since 1991. That system was getting very, very old and needed to be replaced. So one of the major components of EPA's remedial action was to replace that aging system with a new system. So the town of Alamo actually went out and obtained grant money while we were doing the remedial design and got the grant money to install their own air stripper, which is a great news. The new air stripper that the town has installed had a design flow rate of 625 gallons a minute, which far exceeds what we were asking for in our record of decision of 250 gallons a minute. Accordingly, this air stripper replacement that the town conducted fully complied with what we were asking for in the ROD, and that part of the remedial action is already complete. And the system is online. We are overseeing it with TDEC's help to make sure that it is up and running as it should and containing the contamination as it is meant to do. So during the RA, the municipal supply wells, and the influent and effluent finished water associated with the air stripper will be monitored for the site contaminants semi-annually, so twice a year. And those tasks will be oversaw by TDEC. So what exactly is an air stripper and how does it work? An air stripper is a tall cylindrical tube in which contaminated water enters into the top of the tube. The contaminated water is then sprayed over some packing material. And as the packing material helps filter the water down through the tube, high pressure air is blown into the bottom of the tube. The contaminants that we're dealing with at this site are chlorinated organic compounds. And when introduced to air or the environment, they tend to vaporize or turn into vapor, evaporate in essence, rather quickly. So as we blow the air into the bottom of the air stripper, it goes up through the packing material, removing the contamination from the water through this vaporization process. Those vapors are released out the top of the vessel or sent off to treatment. And the clean water comes out of the bottom of the air stripper into either additional treatment or distribution. So as I mentioned earlier, now I'm going to talk about the soil vapor extraction component of the remedy. The soil vapor extraction system will basically be installed and operated to remediate the contaminated soils in the former Ward's dry cleaners area. This was field tested and field verified during the remedial design. So basically what this will do, it will prevent further leaching of contaminated soil to groundwater at the site, and will be reduced by applying a sealant to the existing asphalt at the Ward's dry cleaners area. And the reason why we want to put the sealant on the parking lot is that it prevents two things. It helps us get a good vacuum under the surface, and it will also prevent any future rainwater or storm water from entering through the cracks in the pavement and getting into our system, causing additional leachate. So as part of the SVE Interim Action, performance monitoring will be conducted to monitor the effectiveness of the system, and we will also continue to monitor the numerous groundwater wells that we have throughout the community, which I think there's 12 of them, and will be monitored annually while the SVE system is in operation. And this is going to help us determine overall if the combination of the soil vapor extraction system and the air stripper are doing their job in reducing site contaminant levels in the town. Additionally, we're going to be conducting further vapor intrusion pathway sampling in the Ward's dry cleaner building, and we'll do that through the collection of subslab soil gas samples. And this will allow us also to determine whether or not soil vapor extraction is doing its job of reducing contaminants in the soil. So how exactly does a soil vapor extraction unit work? So what we will do is we'll be installing some wells all around the Ward's dry cleaner building and in the parking lot. And those wells will be connected through some piping and hooked up to a vacuum treatment unit. This will be a small unit on a pallet. It'll mainly look like a large generator. It'll be enclosed inside a building, so you will not be able to see it, and we'll only be operating it during the daylight hours so that there will not be a noise issue during the night. So what that vapor treatment unit does, what the vacuum pump does, is it puts a vacuum on the soil, on those wells that we install. In essence, what it does is kind of like the air stripper. It sucks it basically sucks the vapors out of the soil, because as I mentioned earlier, VOCs volatilize very easily. So what we plan to do is vacuum those vapors out of the soil. They come through the vacuum pump to the treatment unit where the vapors are treated and released as exhaust. And any condensate that we collect will be drummed and disposed of. So now I'd like to talk to you about any potential community impacts that may come from the system. As I mentioned earlier, the newly installed air stripper is already installed, and it is directly next to the old air stripper. The town plans to keep the old air stripper in use as more of a backup redundant system, basically increasing the capacity of water that the town could treat. As I said, this has been in operation since 1991. This new air stripper is updated technology and should not cause any disruptions to the community, as they are already familiar with this kind of treatment. As for the soil vapor extraction unit, it will take approximately 2 to 3 months to construct, and it'll run for a period of up to 3 years or until we meet our remedial action goals. While in operation, the system will be continuously running, causing some noise, like I said, kind of like a generator. However, the system will be enclosed, and it will only operate during business hours, I would say. All vapors associated with the system will be continuously monitored and will pose no threat to the surrounding community. The only disruption I can say during construction, there will be some temporary road closures around where we're installing the system. There's some alleyways that I know are heavily used around that part of the site. We might have to close those off for a time in order to let our crews and construction crews install the wells and the piping needed for the system. And we will also have a fence surrounding our work area while we're doing the construction. On this slide, I wanted to show you where the SVE system will be installed. The street in the foreground is East Main Street, coming east from Johnson Street. The alleyway between the beige building in the foreground, the white building in the background, will have some wells located in that alleyway and some piping. This will all be underground buried piping. This is the parking lot that I'm talking about that will need to be resealed. And this will also have some wells and some underground piping. And then way in the background back there under that tree canopy is the approximate, and I say approximate because we won't be able to figure that out till we're actually constructing the system, is the approximate location for where the actual vacuum unit will be located. This is kind of an overhead view of the same thing. You can see the yellow dots are proposed vapor extraction wells, and the black lines kind of lay out the piping, the assumed piping locations, which, like I said, will all be underground, kind of culminating to the vacuum unit down in the bottom right corner. This is a tentative layout. Again, field conditions will likely change once construction starts, but any substantial changes to this, we'll be sure to let the town know. On this map, you can kind of see the little white dots with MW. This is our monitoring well network. These are the wells that we will continuously monitor annually for the contaminant levels in the town to ensure they're going down. And just wanted to put these on a map so you can kind of see the coverage that we have in the town for sampling the groundwater. In terms of timeline for the remedial action, like I said, the air stripper was installed in January 2020 and it is currently in operation. The SVE system will be constructed during the late fall of 2020 and winter of 2021. I currently have a contractor working on that design, on that work plan. We hope to implement that here late fall, early winter, and it shouldn't take too long to construct, weather dependent. The semi-annual sampling of the city wells and the air stripper will likely begin in early 2021. Like I said, the EPA and TDEC are currently working on that together to come up with a schedule of when we should start that. The SVE system should be completed by March 2021. Then once constructed, the remedial design calls for the system to operate for up to 3 years to remove the chlorinated solvents from the soils, and the monitoring well sampling will begin concurrently with the SVE system coming online, likely in early 2021. Finally, should you have any questions and/or comments for me, please feel free to email or call me. My phone number is 404-562-9587, and I'll try to return your call or your message in a prompt manner. Thank you so much for listening to this presentation today, and have a great rest of your day.